Thanks so much. Thanks for inviting me. It's so exciting to be here and learn so much. I'm here to learn and listen to all of you. So my name is Konstantinos Zachariadis. I'm a professor of financial economics at Queen Mary. We have a wonderful team working on fair compute. We have myself, an expert on market design and governance of systems. We have Ahmed, who's also at QM, who's doing systems engineering. We have Angeliki and Dimitri from the National Technical University of Athens, who are experts in scheduling and algorithmic game theory, and a young student at Queen Mary in the stats department, putting all of us, all of this together. So what's the main question we aim to answer? The main question is, how do we allocate compute across many heterogeneous users, people, conflicting objectives, as I put it there, who may act strategically, and that actually means they may overestimate or underestimate the demands in a way that doesn't reflect the real demand, or don't even know the needs that they have. So that's the main question. How do we actually allocate and schedule compute? So I'm gonna walk you through my way of thinking about this from the macro to the micro. So these are things that you all know very well. We have quite a few heterogeneous resources, and we were told this morning that we're gonna have even more. That's great, and we're gonna put all of them together. And then we have the bottleneck, or rather the demand side. So there's the supply side and the demand side. And so we have researchers who demand this compute. And right now we have schedulers like SLARM and back in the day, Crate Edging, who actually decide who gets what and when. And the aim, at least trying to distill it in a few words, is to maximize throughput, prevent monopolization, and ensure fair access. And that's the key word of my presentation, fair compute. So to focus a little bit more, there are currently, let's say, two paradigms of how to allocate compute, the commercial or private one and the research computing one. Broadly speaking, one of them provides fair access and has other criteria, the research compute, of course, and the other one is profit maximizing and cost minimization. But they also share a lot of commonalities in terms of like sustainability, the energy consumption, on the throughput, and so on. And I think these worlds are coming together. It's like a little wormhole where these two worlds try to collide, as also research compute may rely a lot more on paid service. So opening the hood, and that was very exciting for me, of how schedulers actually work. I have an example from SLARM. So SLARM is a scheduling algorithm that most of the universities use. And it's basically a very simple heuristic formula that takes some inputs, many of which are tailored by universities themselves, by wonderful people like the research computing community who is here. And they basically, for example, backfill small jobs to fill in the nodes. They also preempt if you have paid for your service sometimes. There's a fair share algorithm, which basically has an exponential decay of how long have you had to use the system. So there's quite a bit of things that go there, which are very exciting and very interesting for me. But needless to say that it's a heuristic and one we have to study and see how we actually come up with numbers for these factors that actually reflect the reality on the ground and actually achieve some goals. So that's the main aim. So there are a few paradigms out there how universities actually even implement like SLARM itself and how they play with the parameters. And I picked a few here. There's proportional share, where you allocated some credits, so there's some credit allocation. There are property rights, where there's a lot of paid elements as well, and I put the corresponding universities that use them. And there are funding tiers that we use a lot in these countries, like QS layers, where if you have a grant and you buy some resources and so on. So it's free for all. There is also paid. And of course, Isambard AI has peer-reviewed access. So there are quite a few paradigms on how to do it. And the main aim of this project, of course, one of the aims is to answer how well are these suited, not for the micro, but also the macro, the federated. So how do we view the current limitations from an economist, game theorist, systems perspective? So there are all these heuristics that SLAM is using. And those heuristics, of course, don't take so much into account strategic behavior by the users themselves. And by strategic, again, I mean misrepresentation of your actual needs or uncertainty over your needs. And essentially, one of our goals is to come up with more truth-telling algorithms that incentivize users to actually estimate better, to have higher incentive to estimate better. There's, of course, a structural limit that has to do with moving from the local to the micro to the macro, so the federation system itself. So the first set heuristics and the SLAM, how well are these suited for allocation across systems? Now we're thinking about, going from, small roads to highways. How well can we access the system across universities, across different systems? So we want to have an equitable and scalable solution to what we think the roadmap should be. And the main focus, of course, is engineering to economics. And having done this path myself, I know there's quite a few different worlds. So we want to put the human inside the system. And what I mean by that is treat the features of human behavior as a feature and not a bug of the system as engineering does. So we want to shift from reactive hardware optimization to proactive socioeconomic mechanism design, meaning take into account that actually people are going to try to access these resources and how they may behave and so on and so forth. Of course, until we move to AI agents doing it for us. So how are we approaching this question? We're approaching this question like in different layers. One has to do with engagement, talking to you, doing a survey, trying to assess what is out there and what needs to be done and how the community feels about it, because if the community doesn't embrace any sort of roadmap, it won't happen. So, of course, the beneficiaries here, the university researchers alike, but also the policymakers and the funding bodies, because as an economist, I'm very cost conscious. The epistemic approach we follow, it's a mix of engineering and economics. Game theory is a good in between, where we apply what's called mechanism design, market design to build the incentives. But also we're going to have an engineering approach where we hope to build something like a digital twin of the federated system, so we can simulate different approaches and we can test bet what works and what not, like the optimal versus the heuristics versus what we come up with. And so the outcomes of the project are the present, some critical description of the current allocation mechanisms and what is done here in the local level and national level, as well as in other countries. And the future, a roadmap of how we can go about resource allocation in the federated system in a way that it can be fair and multi-institutional. So we hope to offer some solutions that we can actually then put in practice, hopefully. So to focus a little bit more even on the way I think about it, and here I want to hear a lot of your feedback over break or afterwards, is I think of the resource allocation as a standard like operations, research, set partition problem, where users are strategic, so they may represent their usage either and also may not even know it. And there are different mechanisms. When we talk about econ and finance, we don't always involve money. There are mechanisms like there are markets without money, there are markets with money, and now there are virtual currencies. And at least many universities are moving to what's called cold front. Cold front is a credit accounting system. Universities want to know how much we cost as researchers when we access the resources. The next stage may be that we're actually costed and actually have to pay for that, and so on and so forth, or may not. So we want to study a little bit with an open mind about how research compute is going to be allocated. And again, the big question of the project is what's fair? What's the metric we should use? Something that we call social welfare, like the added utilities of everyone. Balanced usage, what's called supply value, which scientific contribution should be something that impacts. So we have quite a bit of work to do, exploratory and otherwise, but we have a great team. And needless to say, there's no free lunch, as we say in economics. Fairness, efficiency, there might be a trade-off there. So as a community, we have to agree on what's optimal. And without any further ado, I'm going to also put up my survey. So please fill it up. It is for users, it is for admins, it is also for funders. And I know they're all three here. So please fill in the survey and it will help us guide our thinking. What is the current status quo? And I keep talking because I want everyone to have the chance to do the QR code.